A model can generally be thought of as having parameters that one wants to vary and some standard analyses that are wanted for each variation. The common types of parameters that users wish to vary include material properties, position of parts, orientation of parts, and sizes or distortion of part shapes. This is the same solved quick start model as in part 1 of the OERSTED tutorial video. From the menu bar, select Solution, define Parametrics, then Parametric Setup. The Parametric Setup dialog will open. Click the Create button in the lower left corner of the dialog. The Parameter Editor dialog will open. The default parameter. Type, Geometry Displacement, is what we will be using, so we will not change this. However, you may wish to browse the list to see the various parameters that can be set up. Edit the name, steps, and target point as shown here. Click the Select Geometry button. The dialog will close while you select the geometry. Either use Region or Object Selection and click once to select the disk. When the disk highlights green, right-click to end selection. The dialog will reappear and the disk geometry will be highlighted, green indicating the parameter will apply to. Click Apply Create. The Parametric Setup dialog will appear again, but with your defined parameter now in the Parameters Defined list. The geometry corresponding to the selected parameter, the only one in this case, is highlighted green. To visually confirm what the setup parameter will do, select the Validate button on the Parametric Setup dialog box. To visualize the total parametric setup, click the 2 arrows highlighted below to toggle the display to the fully expanded dialog. The defined outputs don't appear under post-processing here. That list is for the temporary outputs that can be obtained from the Analysis menu. From the menu bar, select Analysis, Force, then Amperian Force on Region. The dialog will disappear and the command line will prompt you to select Geometry. Select the disk, right-click to end selection. The dialog will reappear and the post-processing will show Force on the region. Click the Close button. Save this model and from the Solution menu bar, select Run Parametrics and perform parametric analysis. A dialog will open, prompting you for a database name to save the results in. It is recommended to modify the name to OERSTED Quick Start Sample 2 Results. The solver will now iterate through all the requested parametric variations. When it is done, the final parametric table will appear. Click the Graph Results button. Set the Graph Results dialog as shown and click on Graph Results. A graph will appear showing the force versus the parametric step number. Click the Close button for all open dialog boxes. To analyze the defined outputs, select Analysis, then Output Manager from the menu bar. In the pop-up dialog, set the animation slider to the fast end. Click the Animate button. OERSTED will cycle through displaying your plots. Press the Escape button on your keyboard to stop the animation. When you have settings you like for an animation, you can use the Save Animation button to make a video file. To view plots from individual analysis, set the step number, then click the Show Step button. Scripting via the API is the other major way of automating the use of integrated software. Scripting takes more setup time than parametrics, but offers much more power. While parametrics are restricted to studying systematic variation of existing model parameters, scripting offers many more possibilities. To run a script for the first time on your computer, some extra setup will need to be done. Close OERSTED and using Windows Explorer, navigate to the folder when OERSTED is installed. Right-click on the file ies.exe. In the pop-up menu, click Run as Administrator. OERSTED will open in a special mode that sets up the Windows registry for external scripting control. Close OERSTED. The scripting examples are provided in a zipped folder placed in your document folders. Double-click on API Samples folder. Inside this folder is a zip file, also named API Samples. Right-click on the API Samples zip file and extract all. Navigate into the API Samples folder. Double-click the Excel folder to open it, and double-click the file Magneto OERSTED Quick Electromagnet Sample to open it. You will probably be prompted with a warning message about the macro in the spreadsheet. Click the Enable Content button. Now start OERSTED normally and click the Run Magneto Sample button on Excel sheet. While the macro runs, both OERSTED and Excel will be locked. The macro will move the plate by the number of positions and report the force at these positions. When the macro has completed, the spreadsheet will show a data table and plot of the force versus the number of positions. This example shows a very quick, limited use of scripting. Similar targeted tools can be developed as scripts, but much more ambitious custom design tools, even involving the creation of the model, can be created.